Okay, let's take a look at an example of a hypothesis test involving two population proportions and independent samples. This example is going to be similar to 11.1, numbers 17 to 20. Magnotic is a pharmaceutical company that produces an allergy relief medication for pollen allergies called Videxia. Scientists at Magnotic would like to determine whether users of Videxia experience higher rates of insomnia than the general population of people with pollen allergies. In randomized, double-blind clinical trials of Videxia, a random sample of 1,200 people with pollen allergies were randomly divided into two groups. Subjects in Group 1, the treatment group, received 7 doses of Videxia over the course of a week, and subjects in Group 2, the control group, received 7 doses of a placebo over the course of a week. After completing the clinical trials, 56 out of the 700 subjects in Group 1 reported experiencing insomnia, while 36 out of the 500 subjects in Group 2 reported experiencing insomnia. Thus, the evidence suggests that users of Videxia experience higher rates of insomnia than the general population of people with pollen allergies. Use an alpha equal to 0.05 level of significance. For the initial step, like before, we'll summarize the information and identify any point estimates. So there are two groups that this experiment was working with. Group 1 was the treatment group, and in that group, 56 out of 700 said that they experienced insomnia. Group 2 was the control group. They only received a placebo, and 36 out of 500 experienced insomnia. So the sample proportion of Videxia users who report insomnia can be found by doing x1 divided by n1, and that's going to give us p hat 1. So p hat 1 is going to represent that sample proportion. When you work that out, it comes out to 0.08. The sample proportion of placebo users who experienced insomnia is p hat 2. So you do x2 divided by n2, and it works out to 0.072. The Videxia users' sample proportion, the 8%, is higher than the placebo users' sample proportion, which was the 7.2%. This seems to support the hypothesis that users of Videxia experience higher rates of insomnia than the general population of people with pollen allergies. However, we will need to test whether the Videxia users' sample proportion of 8% is significantly higher, and if it is, we would say that it would be sufficient to support that hypothesis. Alright, step 1 is to state the hypotheses. This hypothesis involves two population proportions, so we'll use P1 and P2 to represent those population proportions. In particular, P1 is going to represent the rate or population proportion of insomnia among people with pollen allergies who use Videxia. And then P2 is going to be the rate or proportion of insomnia among people with pollen allergies who do not use Videxia. And so here are the hypotheses using symbols. The null hypothesis is that the rate of insomnia among Videxia users is just the same as the rate of insomnia among all other people. And then the alternative hypothesis is that the rate of insomnia among Videxia users is greater than the rate of insomnia among non-users. So again, on a homework or test or in your own research, all that you have to do is write your hypothesis as symbols. But for clarity, below, I have written these hypotheses as sentences. Step 2 is to verify the requirements for this test. The requirements for conducting this particular test are that, number 1, both samples have to be random samples. Number 2, the samples have to be independent samples. Number 3, the sampling distribution of the difference between sample proportions must be approximately normal. This is the normality condition. And this is true if both of these conditions are true. You might notice that these two inequalities are very similar to the ones that came up in section 10.2. The only difference is that we have to test it twice for the one sample and also for the second sample. And then the last requirement is that the trials must be independent. And the way to check that is to check this requirement that each sample size is less than 5% of its population size. So we have to check both of those inequalities. Let's go ahead and check those requirements. So number 1, the description does mention that it was a random sample of 1,200 people and they were randomly divided into 2 groups. So this is a random sample. Number 2, since the subjects were randomly divided into 2 groups, the selection of an individual for one group did not determine which individual will be selected for the other group. Therefore, the samples are independent. So the subjects were just randomly divided into the 2 groups. They had no relationship and no impact on each other when they were selected. Number 3, the normality condition. And that's verifying these 2 inequalities. And this is a matter of putting in all of these values into these inequalities. So here are the values for x1 and n1, and then here is the p hat 1, x2, n2, and here is the p hat 2. Put all those values into both of these inequalities, simplify, and then they both turn out to be true. This is true, they're both more than 10. And so we can say that the sampling distribution is approximately normal. This last condition, verify that both of these inequalities are true. And here we don't know what N1 is or N2 is. Capital N1 is the population size of people with pollen allergies who use Videxia, and then N2 is the population size of people with allergies who do not use Videxia. These are not known, but we can plug in our sample sizes, plug them into these 2 inequalities, solve for capital N1 and capital N2. We get these 2 results. Since there are tens of thousands of people with pollen allergies who use Videxia, it seems reasonable to conclude that the population is more than 14,000. Similarly, since there are tens of thousands of people with pollen allergies who do not use Videxia, it also seems reasonable to conclude that that population of people is more than 10,000. So therefore, both of these inequalities are true, and we can conclude that each trial is in effect independent. Alright, step 3 is to test the hypotheses. And again, there are 2 and sometimes 3 main approaches to testing hypotheses. You don't have to know all 2 or 3 approaches on a quiz or test or homework. You can choose one approach and just do that one approach. But again, I'm going to go over all or at least most of the approaches in this lecture. So method 1 is the classical or the test statistic approach. The first thing that you want to do is sketch out a normal probability curve, and then use table 5C to find the cutoff value for the region of that curve that represents unusual study outcomes. We'll want to make a note that this is a right-tailed test because of our alternative hypothesis. The alpha is 0.05, that's the area under the right tail. Here's a drawing of what that would look like. We'll go to table 5C and look for a right-tailed test with an alpha of 0.05. 0.05, right-tailed test. That's 1.645. So that's our critical value. That's the cutoff for where the right tail begins. The next thing that we'll do is calculate the test statistic. The test statistic is a z-score. And remember, in general, a test statistic describes how far above or below a study's outcome is from the mean. Here's the formula for this particular test statistic. And to calculate this, we'll have to calculate a few things first and plug them in. So we'll need in particular p hat 1, p hat 2, and this p bar. Earlier we calculated p hat 1 and p hat 2. There's the 0.08, 0.072. What about this p bar? That represents the pooled estimate for the proportion. And it can be found using this formula. x1 plus x2 divided by n1 plus n2. We'll put in those values for x1 and x2, n1 and n2, work that out, and it comes out to 0.07667. So now that all of those values are found, we can put in all these numbers. This is the p hat 1 minus p hat 2. This was p bar minus times 1 minus the p bar times the square root of 1 over n1 plus 1 over n2. The original formula is up here. So I've just plugged in all those values into this original formula. And when you do, it all comes out to 0.5135. The last thing is to determine whether the test statistic is inside the critical tail of the curve or outside. Here's our tail, and 0.5135 is going to be somewhere over here. It's not more than this value. It's somewhere on this side. So our test statistic is outside of the critical tail. And here's a drawing of that. So it's outside the critical tail. And since our test statistic is outside the critical tail of the curve, then this study's results are not unusual, not significant, and we would not reject the null hypothesis. So here's method 2, the p-value approach. To calculate the p-value, you would want to use a graphing calculator. On the Casio graphing calculator, you would take these steps, go to your stat window, choose test, which is F3, then choose Z, which is F1, and then choose 2P, which is F4. And then you'll be given these options. You want to put in the value of the inequality of the alternative hypothesis. This was greater than, so greater than is what we'll choose. Then you put in x1, n1, x2, and n2. Put in all those values and calculate, and it will give you the p-value. Kind of similar for the TI 83 and 84. You'll go to Stat, scroll over to Tests, scroll down to the function called 2PropZ test, enter in the x1, n1, x2, n2, put in the direction of the inequality for the alternative hypothesis, and then you'll get the p-value. So when you do that, you get a p-value of 0.3038. What's the meaning of this p-value? It's a long explanation, but this p-value is the probability that insomnia would be reported by 56 or more out of 700 people with pollen allergies who were randomly assigned to use Videxia, and that insomnia would be reported by 36 or fewer out of 500 people with pollen allergies who were randomly assigned to not use Videxia and use a placebo instead, assuming that the null hypothesis is true. But you want to keep in mind that in general a p-value is a probability, and it's just telling us the probability that we would get this particular result from the study. So this p-value is more than alpha, and for that reason our study's results are not unusual, and we would say that we do not reject the null hypothesis. And so our conclusion is there is not sufficient evidence to conclude that the users of Videxia experience higher rates of insomnia than the general population of people with pollen allergies.